Okay, hello guys. Today I'll talk about the polygons. Okay, so let's move to the first slide about the sum of interior angles. Okay, so we have a formula to discuss about all the sum of interior angles right here. We can just set as n minus 2 here's the total bracket times 180 degree. Okay, so for example, like here we have a pentagon, and we knew the pentagon has five sides, so that is n equals to 5. Okay, that's pentagon. And we can set here as 5 minus 2 times 180 degrees, that is 540 degrees, okay? So why is that? Because after you're drawing the pentagon like here, and you can use into actual lines to divide it into three triangles, okay? So in each triangle, we can set the total interior angle as 180 degrees. So we can set that is 5 minus 2. There are three triangles here times 180 degrees. That is 540 degrees, okay? That is for pentagon. And for hexagon, we knew that here, hexagon, we have six sides. So here is for hexagon. So also you can draw actual three lines, like here. So we have said hexagon can be divided into four triangles, and we knew that in each triangle, the total interior angle equals to 180 degrees, right? That is 6 minus 2 times 180 degrees, okay? So what about octagon? So here we have a side, so we can say it can be divided into six triangles, that is 8 minus 2 times 180 degrees, okay? Total sum of the angles here equals to 1080 degrees, okay? That is for the sum of interior angles right here, okay? So what about exterior angles of polygons? So we can say all of the polygons, they have the same value of exterior angle, that is 360 degree, a constant number, okay? So do not
Maybe
need to know
later when
why
we
it's
learn in the A-level lessons or IB lessons, I believe you will know why the total sum is 360 degrees, okay?
So here, for the regular polygons, we can set each exterior angle as 360 degree over n because we have n side, we have n angles. So each exterior angle equals to 360 over n. Okay. So for each interior angle, that equals to 180 degree minus the exterior angle. Okay. So for example, like here, we have a regular decagon, decagon. So here the side number equals to 10. So that's each exterior angle equals to 360 degree over 10 equals to 36 degree, okay? And for each interior angle equals to 180 degree minus 36 degree equals to 144 degree, okay? That is it. That is for each interior angles, okay? And we can say here, if you want to find the number of sides, also is a very interesting problem here. Like for example, each interior angle of the regular polygon equals to 162 degree, okay? And we can say here, using the formula 180 degree minus 162 degree, and then equals to 18 degree. So you can use the formula that 360 degree over 18 equals to 20. So now we have 20 sides of the polygon, okay? That is how we can find the value of the number of sides. And also we have a vertex of the polygon because we knew like for here, like for example, like here, you can find this value and this angle, they're on the same side, right? Or the same lines. So the value or the sum of the angles here equals to 180 degrees, okay? That is it. So here is for some example for you. If you want to try yourself, you can just pause the video and do it yourself. And if you want to follow with me to solve the problems, you can keep on going, okay? Let's move to the first problem, like here. Calculate the sum of the interior angles of 12-side polygon, okay? So we can say here, because the 12-side polygons, so using the formula, we can first find the exterior angle, right? That is 360 degree minus over n, right? So that is over 12, that is 30 degree. So the interior equals to 180 degree minus 30 degree equals to 150. Also, you can use the formula that is like here. For here, we can set n minus 2 times the 180 degree means the total interior angles. And we have 12 interior angles in total. That is 12 minus 2 times 180 degree over 12, okay? So all the value equals to 150. 50 degree, okay? That is for first problem. And for second problem is that each exterior angle equals to 15 degree, right? So you can use the formula 360 degree over 15 degree, right? Okay, and we need the value here as for 6 times 4, that is 24. So we have 24 sides in total, okay? That's for problem 2. And for problem 3, I said a regular polygon has 18 sides and calculate the sides of each interior angles, right? So here we can say, using the formula, first calculate the exterior angles here, 360 degree over 18 equals 20 degree. So for interior angles equals to 180 degree minus 20 degree equals to 160 degree, okay? That is for problem 3. And for problem 4 is that 4 interior angles of the pentagon are 90, 100, and 110 and 120 degree. Find the fifth angle. So we can first calculate the total interior angle, the sum of it, right? So that is 5 minus 2 times 180 degrees. That equals to 540 degree. And then to minus 90 degree, 100 degree, 110 degree, and 120 degree. Okay. So the value here we can set as like 540 degree minus 200, and then that is we can set here is for total is for 440 degree, right? Oh, sorry, 420 degree, right? 420 degree. So that is for 120 degrees. So another fifth angle is 120 degree. Okay, that is for pentagon. And for the last problem is that the interior angle of the regular polygon is 11 times to the exterior angle, right? So we have said here, interior equals to 11 times exterior, right? So we also knew that exterior equals to 360 degree over the n, and we knew that interior angle plus exterior angle equals to 180 degree, right? And you can calculate the exterior using the equation to the third equation, that is 12 exterior angle equals to 180 degrees. So each exterior angle equals to 15 degree, okay? Equals to 15 degree. So we can say here the number of the side of here is n equals 360 over 15 degree, okay? So the value here equals to maybe for like 60 over 15 is 4 times 60 is 24, right? So we have 24 side in total, okay? So that's for today's our lesson. We already learned about interior and exterior angle. I hope you can just try to solve for such problems. You can clearly understand how to calculate the interior, exterior, and find the side numbers. Okay? So see you next time. Bye.